Alrighty, let's take a look at this question. So we're going to graph the function that we have here without a graphing calculator. And you'll notice that it's an x squared, so it's going to be a quadratic function, which when we graph it looks in the shape of a parabola. So I'll just start drawing the axes and then we're going to get into it. So first of all, we know a parabola, I don't know what we know that negative in front of x squared means the parabola is going to open down. But other than that, right now we can't tell a lot about that equation. We could get the fact that the y-intercept, which is when x is 0, we could take that equation and replace x with 0, and we would get a y-intercept of negative 19. So we do know we have a point at 0 and negative 19 somewhere down here. But other than that, the form that that equation is in right now is not very useful to us. So what we're going to do instead is we're going to complete the square with that equation so that we can actually see what the vertex would be. We can get it into vertex form. So to do that, we are going to, first I'd like to group these two x terms because that reminds me that I need to take or factor out that negative 3. Whatever's in front of x squared needs to be factored out. And it comes out of just those first two terms, the two x terms. So out of the first term, we're left with x squared, and then 18x divided by negative 3 would be negative 6x. Then we leave a little room, write the minus 19 on the outside there. And then we want to come up with a number such that when we have this trinomial, we can factor it into a perfect square binomial. So to get that missing number, we would take negative 6, the coefficient of the middle term, and divide it by 2, and then we're going to square that. So that would be negative 6 divided by 2 is negative 3, squared would be positive 9. Now, we can't just willy-nilly add 9 to an equation, so we're going to have to subtract 9 times whatever number was in front, so negative 3 in this case. All right, so we're one step away from having vertex form, where we know what the vertex is. So we factor the x squared minus 6x plus 9, but it will always factor into the same two factors. So you really just square root the x squared, use the same sign as the middle term, and then you square root the last number, the 9. And that's how we get x minus 3 squared in this case. Then, this last part, we just figure out what the value of that is, do the multiplication first, so negative 9 times negative 3 would be positive 27. Add that to negative 19, and you would get positive 8. And there we go. So, our vertex is basically these two numbers, opposite sign of what is inside the brackets there. So our vertex is 3, 8. We know the negative 3 in front indicates that the parabola opens downwards. Looks like that, not with a V, but, and so let's see if we can plot some more points. So we have 3, 8, I don't know, I'll put that somewhere up there, 3, 8. And it opens down, so that's going to be our maximum point. We know we have this 0, negative 19, and using our symmetry, we know the axis of symmetry would run through the vertex, so at x equals 3, and this y-intercept we found would therefore be 3 away from the axis of symmetry. So if we go another 3 on the other side of the axis of symmetry, we'd have a point at 6, still negative 19, like that. All right, so we've got 3 points so far. Now, some more points that would be good to get would be our x-intercepts. To find our x-intercepts, what we're going to do is set y to 0, and we could use the original equation, but we'd have to use probably factoring, actually probably quadratic formula, or maybe complicated factoring, I'm not sure. But if we use this vertex form or standard form, then what we can do is just isolate our x. So y is 0, we have this equation, and we are going to isolate x. So first we subtract 8 from both sides to get negative 8 now on the left side, equals negative 3, bracket x minus 3 squared. Then we divide both sides by negative 3, and that will become positive 8/3. I can see this is not going to be pretty. And then you would square root both sides to get rid of the square. And that would give us plus or minus, because when you square root both sides, you could have either. And let's see, that would be root 8 divided by root 3, lovely, equals x minus 3. And then we're going to do a little simplifying with that. So we have square root of 8, which would be 2 root 2 over the square root of 3, but we'll need to rationalize that because we can have a square root in the denominator. Now, if this is something you haven't done yet, then you wouldn't be expected to do this. You'd just write it as a decimal. But I will finish it up just in case. Okay, and then we're going to add 3 to that side as well, so we'd have a plus 3. All right, just fixing that rationalizing. So 2 root 2 times root 3 would be 2 root 6, and then on the bottom, root 3 times root 3 would just be 3, and then we have a plus 3 at the end. You could get a common denominator. Oh, I forgot my plus and minus. Yeah. Get a common denominator, and then that could become 9, just switching up the order here, plus or minus 2 root 6 all over 3. And guess what? That could actually be found with quadratic formula using this original equation. So our x-intercepts are terrible, but they would probably be, you could figure out the decimal values for each of those, but somewhere in here would be my guess. This one would be the 9 minus, because it's got to be smaller than the other one, 9 minus 2 root 6 over 3, comma 0. And this one over here would be 9 plus 2 root 6 all over 3, comma 0. And now we could probably draw a pretty good parabola through that. We now have 5 points. We have our x-intercepts, we have our y-intercept, and we have our vertex. So not a bad graph, and yeah, there we go. Hopefully that helped.